back there. It's fine. Cool. So it's like my first time on stage, and I'm straight coming to the stage after a 16-hour flight. So I hope it will go well. So pretty long header for a talk, but I will try to explain what I mean by this header, and I hope you just have fun. Maybe we will take some takeaways. And let me first introduce myself. As been said, my name is Artur Oleyarsh. I'm working as a security researcher at Palo Alto Networks. I'm coming to you from Israel, and my current areas of research are around security-related topics such as vulnerability management and vulnerability research in open source ecosystem and cloud-native technologies. And outside of work, I really like to climb a lot outdoors. So if you want to hear funny stories from outdoor climbing, you're welcome to grab a cup of coffee with me. And today I want to talk about malicious packages in open source, and how something that is well documented by the community and shared across different type of public repositories are not always to be shared, and how it used by different attack groups, and maybe not an attack groups, but people with some security skills and some level of development skills to initiate their own attack and mimic some active threat group. But before that, I will make a bit of introduction of what are malicious packages, how they differentiate between the vulnerable packages, and we talk about open source software in general, why we love it, why we use it. I hope everyone knows a little bit, at least, about open source. Someone here is using open source? Maybe some hands. Yeah, cool. Okay, fine. And as I go, I will maybe make some points of what can be done to avoid and falling into the trap of using the malicious software. So we all like open source software because we all like something free, right? But not always free is good. Also, there is a community behind those projects, brilliant people, and when we contribute, we like to be to have an influence, to be a part of a bigger family, right? Over that collaboration and contribution to different kind of projects which are consumed by a lot by different companies. So basically, when we dive in and look at the ecosystem of open source, we can divide it into three main points. And the first one, and maybe one of the main ones, is the maintainers and the collaborators of the open source projects. Those people who are creating the solution we use, they try to make it creative and effective. And they upload it to different package managers, public or private repositories, which lead me to the second point. And finally, we have the end users, which are the developers and the DevOps, or maybe security practitioners, which are consuming these projects, right? But there is something that is under the radar and not seen as much, so and which unite all the 3 points. And it's like that all these all these building blocks are built on a trust relationship. It's not written anywhere, but like maintainers will trust the end user that they will use the projects without any malicious intent. For example, if it's like a tool like Metasploit, which is intent for red teamers to pen test the systems of the company with not fall into threat actors, so they will use to attack and use it as a cyber weapon, for example. Package managers are trusting the developers that they will commit legit code, right, and not malicious one. And the end users will happily receive non-malicious content, so they can use and solve quickly problems. So, as I said, it's a relationship that built on mutual trust. And if you're aware of Silicon Valley, so you basically maybe know this scene and the trust relationship between Bachman and the Shinyan. So open source is evolving. Millions of downloads for packages on a weekly basis. On monthly basis, there are thousands of packages uploaded every month. And basically, one of the reasons that open source is such a famous subject is because our developers want to solve problems pretty quickly. They want to deliver fast. Why should I develop in-house ready solution like tailor-made for my company when I have something ready out there that I will modify a bit and use it in my project to solve my problem? So basic scenario, as we know, goes like this. We have a user, which is the developer in some company. He's searching for a solution on the web, let's say Stack Overflow or GitHub issues. He's searching for some solution to a problem. Maybe someone solved already something similar. And let's say he finds a solution in form of, okay, you can use a function X from package Y. And let's say we are talking about Python here. So if you don't have the package Y, please go and pip install it. So our developer goes and installs the package. The package is delivered to the endpoint of our developer, and all good. He tests it. The package which he done before he downloaded the package, it looks legit maybe, and everybody's happy. We can go and grab a cup of coffee. But we don't live in such a perfect world. And the packages that we are installing are not standalone packages. They are coming with a lot of dependencies, transitive or direct dependencies, and sometimes even transitive dependencies can introduce a logic flaw. And then all the package and even the final solution by a developer which consuming the package will be exposed to a security vulnerability, right? But such an issue can be solved on the developer solution level or on the transitive dependency source code level. And it's all good. But the point I want to make here is that we are talking here about a dependency and a legit package with a legitimate code, which has a flaw in its logic. For example, there was no sanitization for user input or something like this, right? And this introduces a security vulnerability. But this not makes the package malicious. It makes the package vulnerable. And sometimes people in the community confuse between the two terms because the vulnerable packages are not malicious packages. And sometimes the stuff that we see that is shared across the open source ecosystem are not always what you think they are and not coming with a good intent. So we see a lot of stuff shared in open source ecosystem. And we see stuff such as like different proof of concept for old or new vulnerabilities, which are usually used by red teamers or security researchers to try and see if some systems are vulnerable. Also, we can see malicious packages uploaded to different package managers or source code of malware are being shared in repositories such as GitHub, registries, sorry, such as GitHub. Which are info stealers, crypto mining. Sometimes it's something that's called protestware. I don't know if somebody here heard about the term. Somebody heard about the term protestware here? Nobody. Good. So protestware is a thing that we have a legitimate famous package, well maintained, with a maintainer which is well respected in the open source community. And at some point of time, he decided to deliver a point on some subject that's happening in the world via his software because he has that influence. So he commits a code, and from now on, a well-maintained package has an unintended behavior, and I will share with you a couple of examples. And of course, we have the offensive weaponized tools such as Metasploit, which in wrong hands can be used as a cyber weapon. But today we are here to talk about a malicious code. By the way, about the POCs, we saw in examples where POCs that were shared publicly contained malicious code and were not actually a POCs. So they were targeting security researchers and they were targeting red teamers. So what are malicious packages? Malicious packages, as they sound, are from intent. And the intent is to harm a system. And usually it's to steal sensitive data and transform it to the endpoint controlled by the attacker. It can involve your endpoint into a crypto mining activity, protester, which we covered, and you can imagine any malware basically you can think of. And actually how attackers are tricking us into installing those malicious packages. Because of malicious packages actually are a very good technique for a stage 1 into supply chain attack. Attackers use malicious packages to as droppers for a more complicated second stage of an attack. And they do it using various techniques. And I mentioned a couple most famous of them here. It's not everything, but I don't have enough time. So the first one is, I think, most famous one is typo squatting, is where an attacker uploads a malicious package to say npm or pipey and names it with the name of a famous package, but with a tiny typo. So requests to the left is a famous package in pipey, and let's say attacker uploaded request with S, which is a malicious package, and let's say developers can step twice on the letter S and install the malicious package for our developer. Repo jacking, which stands for repository hijacking, is a way that a developer, an attacker actually takes over a repository on GitHub, which was a legitimate and famous repository before. And I will go over how it can be done. And dependency confusion and dependency hijacking are both sometimes confused in the community. Dependency confusion is where a company holds a private repository with some private package, and attackers know about such a private package and upload the same package but to a public repository. And what happens when some code fetches the code from that private package? Some package managers are confusing and will not fetch from the private repository, but from public repository, which is controlled by the attacker. Dependency hijacking, on the other side, is a way that attacker controlling a code, a code that is consumed by some dependency. And hacked accounts is a pretty trivial one, but I want to stop for a minute and go over what it means repository hijacking. So repository hijacking is an attack allowed because of the feature in GitHub that allows for a user to change his username. So let's say we had a legitimate user which maintained an awesome project, and now he decided to change his username to new legitimate user. So when you type in the browser a legitimate user awesome project, it will redirect you to the new legitimate user awesome project from now on. So what is the problem here? Let's say an attacker is now able to register a new user with legitimate user because now this username is available. And he will open a new repository, which is called awesome project. From now on, if you will enter in your browser legitimate user awesome project, it will no longer redirect you to the legit repository. And actually, the attacker can commit any malicious code. So why it is important? The result can be, for example, imagine that there is a project or some package that has a dependency, and that dependency referencing this GitHub repository and uses its code inside it. And the maintainers of that dependency didn't change the URL because they didn't know that the user was changed. So now the dependency will deliver malicious code to our project, which now we see here like a chain of repository hijacking, which caused to a dependency hijacking. So repository hijacking last year and 2 years ago was a really, really famous and effective way of initiating first step of a supply chain attack by different kind of attackers. But GitHub were aware of the issue and will later address how they solved it. And for example, second thing that the attacker can do, he can upload now a malicious package with the setup to PyP, for example, with the following setup py file, which will be executed during the installation of the package. And as you can see, he creates a temporary file and downloads from GitHub repository executable and execute it to deliver second stage of attack. So you can ask me, Artur, why he would put the GitHub link there? He can put any link there as he wishes, right? Because our victim already did the pip install thing, right? So anybody can tell me why he would put the GitHub link there. Any ideas, maybe? Okay, so some endpoint protection mechanism can see a third-party call to GitHub, and they say, okay, GitHub is whitelisted URL, a well-known one, and it will allow the traffic go on. So basically, it's a way to bypass some EDRs. And also, by the way, creating temporary folder and downloading executables to temporary folder is also a way of evading EDRs, but I will not expand on it because I don't have much time, unfortunately. So GitHub was aware of the issue, and they wrote a really nice blog about it. I really suggest for you to read it. They call it How to Stay Safe from Repo Jacking. And they explain how they protected their users so they will not fall into the trap. And I want to stop and show you one of the examples they showed there. And it's basically checking the identification number of the repository, because repositories are not only names. They have ID numbers. So if you check those within your code, you're pretty much protected from repo jacking. So please stay safe. So why would you even believe to the attackers and download the malicious code? Is because the attackers know what we believe in and why we trust open source. For example, they can use the starjacking technique, which basically spoofing a popularity of a package. When you go to a PyP index, you search for a package, you can see on the side a number of stars, number of forks, and etc. Everything can be forked by an attacker pretty simply. And when you will see some package, even if it's typo squatted, you can see 50,000 stars. You can see, okay, pretty much legit code. I will download it, and you will fall into the trap. They can make fake contributors. They can make fake company names. They can basically do everything, so you will believe in what you see. So as we can start to have some feeling that we have two situations here. The first one is where the malicious or threat actors are creating malicious packages and using different types of supply chain attacks to compromise systems. And on the other hand, we have legitimate, well-known maintained packages with well-respected contributors and maintainers, which in some point of time, due to some commit, now have an unintended behavior. So what makes us trust in open source, as we already mentioned, it's a popularity of a package. It's a package that maybe it's well maintained because we see constant releases are going out, which solve different type of issues and stuff like that. And there are a lot of stuff that makes us believe that the packages are legitimate. Basically, the code is open source, so we can view and check if the code is legit, but we are not doing it. So some examples, I came across a funny commit, which basically it was an issue and then it was a commit. So basically instead Russian pages play Ukrainian anthem. So I decided to check. It was about Sweet Alert 2 package. It's a package that has over 500,000 downloads weekly. And the commit just stated the following thing. It checked if the browser was opened on a Russian domain by checking its extension. If so, it disabled any mouse activity. It created a new audio file, embedded into the document object model, and played it in loop. So imagine yourself sitting in front of a computer, cannot do nothing, and just listening to the Ukrainian anthem. Pretty funny. And another famous thing that was made a lot of noise in the community is a colors.js package with over 50 million weekly downloads. had the following commit. A maintainer committed a module with a funny picture with ASCII characters, as you can see, and then used this model in infinite loop inside of the main JavaScript file of the package. And basically, it DDoSed every project that was referencing this package, which is pretty much thousands and thousands of projects. Basically, the community paid attention pretty fast to all this, and security advisory was issued. And this teaches us the lesson that famous packages are not always safe. So please don't trust everything you see. Those are pretty much unharmful examples, but I can give you a talk of 40 minutes of examples that are deleting files, crypto mining activities, and it all comes from legitimate packages with like millions of downloads weekly. And I want you now to take you to the other side of malicious activity. And we conducted the research on PyP index one day. And one of our researchers paid attention to 6 packages which had a really strange behavior. So after digging deeply inside, we saw that these packages were targeting Windows users, and it was telling personal information, crypto wallet information, and send it over an endpoint to sending it to the endpoint of an attacker control. So basically, how we did that, it of course did it by creating a temporary file, and while the user was installing the package, it downloaded the malicious file from an endpoint controlled by an attacker, and then it executed the file, which delivered the second stage of an attack. So setup pi was a dropper for the second stage. And when we looked at the second stage, we saw that it was trying to decrypt an information that was encrypted by crypt protect data, which is a data protection API by Windows. We saw that it was trying to geolocate the victim and collect some information about his friend's activity on Discord channel, on Discord application, sorry. And finally, they set a webhook and set all the information they collected to the associated channel. So basically, the attack goes like this. Pip install malicious package, the package delivered, it makes a call to an attacker domain, it sends the exe file to the victim, decrypts information, and delivers it to the endpoint by the attacker, controlled by the attacker, which is a Discord channel. So basically, 6 packages were created with over 150 downloads, and the different names of the attack was associated to the attack. And basically, we look at the code and we realize that we already knew this second stage from somewhere. And basically, this was an attempt to imitate a well-known WASP stealer campaign. And it was an configured version of WASP stealer 116. And what made us to believe that is that this attack was not that complicated as WASP did. It was not that, it didn't have this level of sophistication and obfuscation that WASP did. And also, WASP stealer source code was leaked on GitHub, not leaked, but was publicly released on GitHub. And now it is deleted, as you can see, because the community reported on it. It contained different attack names. It didn't use typo squatting techniques. So basically, because of WASP stealer was such well documented by different researchers, which is good, and also the code was shared publicly, it made someone with some set of skills to imitate a well-known attack campaign by himself pretty much easily. So what we can do about it? So we see some companies trying to protect themselves because, for example, Python package index don't have so much protection mechanism. And one of the ways is to use placeholders. Placeholders are used as a type of technique that where company reserve a name for a package. And when they reserve a name for a package, a malicious actor can't use this name anymore. And as you can see, Yandex and NVIDIA is doing it. And for example, if you view in one of the packages, it says, this is a security placeholder package. If you want to claim the name, please contact us. So also you can, for example, NPM allows you to use scopes, organization scopes. So you can publish a package Y under organization X scope. So basically, no attacker has a control for your organization scope. So basically, he cannot forge or do something malicious. And please report any malicious activity or suspicious activity that you see in open source, which is will help, like with the WASP case, which was shared publicly. You can also scan for packages before you install them, using such projects as OpenSSF, for example, which shows you how much you can trust some package. Please scan for your dependencies, transitive or direct dependencies for security vulnerabilities, which is a really good practice, because even sometimes the transitive dependencies can crash your project. And please don't believe what you see in open source, because attackers will always try to convince you that what you see is true. And not everything that is popular is also safe. So thank you for coming here. If you have any questions, I would like to answer.
Thank you, Artur. If you have questions, just remember there's mics here in the center of the aisle.
Karlo, your National Cybersecurity Center, Finland. Just wondering, has there been any discussion in the open source community to build up some sort of chain of trust among the developers, so that you could actually verify who is actually submitting the code?
Yeah.
Because I mean, there has been, you know, the XZ case very well. So there is a mystery actor X appearing and trying to submit code and build up its repo, but no one has met him.
Yeah.
But maybe signing or actually verification that this has a legit government ID or something like that.
Yes, it's a really good question, and it's like kind of a blind spot, because I'll try to explain. Because when you see someone contributing to a project and people are approving his code, right? People can relate. They basically can see an avatar, right, on GitHub, for example, and they can see a different kind of contribution he already made to different other projects. And if like those are a legitimate contribution, and he like have like a lot of legitimate activity, so we will not trust him, right? But this is a bit of a blind spot, because there was a situation where a lot of users were gaining popularity, and they were doing a great job for like 2 years, and then they made a malicious move. So it's a blind trust, as I mentioned. I don't know if it answers your question, but usually people, you know, someone contributing, the one with the rights to push the code, push the button and merge the code.
Wasn't that also part of the SSH lib ZMA thing, the problem, right? Yeah. Mm-hmm.
Yeah, it's exactly the part. Yeah, yes, that's what I meant.
Maybe even provide a trusted repo thing where you actually have made some verification of actually the physical identity of the developers, so that you actually there has been a method to actually verify that all the developers of the project, they are real people and not fictitious persons.
Yes, this can be an idea, but it also will slow down some activity in open source, and people will not like it. I assume, yes. The idea to be like, you know, to build that trust, you know, whether it's physical identification or other thing, this stuff will take time. Changes are also not so much accepted by the community for the good and for the bad. But I agree with your point that
There is, I think, a nice example that I just wanted to mention, like on, for once in the IT security world, we have a positive example. There is a app store, a custom app store for Android called F-Droid, which requires every commit to be like fully open source and every app. So you need to see the source code and people need to review it before it gets like included into the app store. And then they have reproducible builds, which is also a really cool concept. So just wanted to say that might be an option for some things if anyone from GitHub here is in the room. I don't know.
Yes, there might be different kind of solutions to build the trust, and so we can avoid malicious code being pushed to different projects. I think that there is a place to contribute such an ideas, for example, the OpenSSF project.
About 3 months ago, a popular Linux package, the XZ, the tool is for compression and decompression, and there is a
Libelzeme, you mean, yeah? You mean the Linux incidents?
yes.
Yes.
How can we prevent this? The attacker become a trusted contributor and hide in this repo for about maybe 2 years. And how can
Yes, yes,
catch
yes. This is pretty much hard to avoid, but as far as I know the details, I might confuse. Actually, the maintainer of the package had some personal issues, and it stopped from him to deliver and approve code fast as people wanted. And those people who like pushed, psychologically pushed on him and to deliver solutions were actually the threat actors, which use this technique. So he will see that they have a lot of contribution and they well respected, and so by the end he gave them the permissions to commit code to the repository, and that's what happened.
Time for one more question.
Thank you very much for your presentation. Very nice.
Thanks.
I was wondering about the use of machine learning to be able to detect that,
Amazing.
if you thought about that.
Yes, I think the community is going towards some of the machine learning solutions, whether it's when you verify code that is pushed, whether it scan for logic flaws, even for vulnerabilities. I try to play with something like that. So definitely the community is going toward it, and I really hope it will help and make all the ecosystem pretty much safe. The funny thing about it that some of the machine learning projects are open source, and they themselves are sometimes being compromised. So
Excellent. Let's thank Arthur for a fantastic presentation.
thanks.